All right, super quick. So we're going to go over what is a remote header, but really quick, we're just going to go over this pen and paper stuff really quick, and promise me, just give me like 3 minutes of your time, and then we're going to go into the machine room and actually take a look at it. So first off, you got different piping approaches. So one of the piping approaches I'm going to call traditional or conventional. Maybe there's another name for it. Let me know in the comments below if you know the another name for it. But basically, what happens is you have your machine room. So I have compressor 1, 2, and 3, 4, 5, and 6. Right. We have suction group 1, which is 20 psi. Suction group 2, which is 55 psi, right there. Right. So you have this discharge header, goes up to the condenser, condenses down to a liquid. Now this is a liquid line. This liquid line goes to the receiver. Out of the receiver, you have a liquid header. Out of that liquid header, you have direct circuits. Right there. So you got, circuit 1, circuit 2, circuit 3, circuit 4. They all go down. It hits the TXV. The TXV goes to the evap coil. And then now on the suction side, you pipe it back to the suction group that you want. So if we want a 20 psi suction group, we go to the 20 psi suction group for low temperature. We want a medium temperature. We pipe it back to the medium temperature suction group, right? And so now every single circuit is clearly defined. Circuit 1, circuit 1, circuit 1, circuit 2, circuit 2, circuit 3, circuit 3, circuit 4, circuit 4, right? And they're all in the machine room. That's a traditional approach to the piping. The drawbacks to this is, the advantages to this, it's easy to work on, easy to understand, and it's easy to wire, easy to get communications to. The drawbacks is very expensive. The piping is very expensive. It's more piping, more brazing, more armor-flexing. Labor-intensive, expensive piping. Now, number 2, and it isn't always practical to run 26 lines across your store. Now, approach number 2 is a loop system. Loop systems are very difficult to work on. At least I find them very difficult to work on. The valves are sometimes in random locations around the store. Sometimes they're on top of coolers, underneath coolers, on top of cases. Hard to deal with, hard to work on, okay? My opinion. So the way the loop system works is very similar, as in that, you still have your discharge line that goes up to the condenser. We have compressors 1, 2, and 3, 4, 5, and 6. Two different suction groups, just like before. Condenses down into a liquid, goes to the receiver, comes out here. This is your liquid line. Loop 1, loop 2, right? So loop 1, let's say we'll go to one side of the store. Loop 2 will go to the other side of the store. Out of those loops, you're going to have branches that come off to your cases. So they're literally going to put T's on the loop or drill holes in the loop circuit, and it's just going to come off. You can almost view this as an extension of the liquid header, okay? And then you're also going to have suction loops that go as well. So this is a low temperature loop, and this is a medium temperature loop. And so you're going to tie your cases in. So this is going to branch off, go to the case, go to the TXV, go to the evap coil. Then it's going to branch in to the suction loop and go back to the low temperature side. Low temperature side. This side is branching out, going to the medium temperature side, the medium temperature side. Does that make sense? So that's how the loop system works. And the advantage of this, low cost on piping. So it's easier to just run these 2 pipes to different sides of the stores and then branch off. It's cheaper, and sometimes in more complex stores, like an older store, like a renovation of a 100-year-old, 200-year-old store, it's a little bit easier to install these systems in that type of setting. That's why you might want to do this. It's harder to communicate with the equipment. It's harder to work on in the cases when you have to brazen a EPR valve inside one of these cases. It's more difficult to deal with, but it does have its advantages with installation. Now, we have a remote header. What is a remote header? A remote header is kind of the marrying of these 2 philosophies, okay? So much the same as the others. You have a discharge header that goes up to your condenser, condenses down, goes to the receiver. Now you have a liquid header. Now let's say we want to put in like frozen food cases in this section of the store. So what they do is they run a large pipe similar to a loop system and a large suction pipe similar to a loop system, but they run it to a header, a remote header. So it's a centralized location where they will then come off with circuits just like a branch system, not a branch, just like a traditional system will. They'll come off with circuits, so circuit 1 or circuit 2, and then they will go right back to the same centralized location. So rather than it kind of running around the store and it branching off like a loop system, it goes to a centralized location and then comes off like a traditional system, and all the valves are typically at the centralized location rather than underneath the case or on top of the case or on top of a cooler or in all different locations. It's centralized to this one area, and you'll see as we go to it. All right, just really quick, just want to mention also, like, so for this remote header over here, right, so there is no compressors over here, okay, and that might seem confusing to you, but it works off of pressure just like a case does, okay. So you see this high pressure 180 psi line comes out here, right, goes to the case, comes around here. Now this is about 20 psi over here, right? So high goes to low. Those compressors create a low pressure condition at the compressors, right? They compress the refrigerant out of the compressors, causing, you know, like a vacuum condition inside the cylinders of the compressors, which causes the refrigerant to flow into them, right? Also, another way to think about it is this is constantly flowing. If we were to valve this off, or right here, this would eventually flow to the point where this would raise to the same pressure as the liquid line up here, right? So this is constantly having that 180 psi push it through, which pushes the refrigerant all the way back to the rack. So you don't need a compressor over here. It runs off of pressure, and you know the pressure is created by the compressors at the rack. Just wanted to throw that in there. Okay, now we're going to go back to the real life rack, and we're going to look at that. All right, so as you can see, this kind of system has an advantage to like the technician, where we can just come here, troubleshoot the valves, valve it off, you know, bring your recovery machine, plug it in where you got to plug, do your thing, right? Super easy to work on, right? Comes out. So that's why they kind of make these kind of systems. They're far easier to work on. Electrical is easier too. You see these little, you know, electrical wires. All they do is they go up to that box, they come around here, and they go inside these electrical cabinets right here. Right, you got all your contactors, you know, you got everything. And you know, one of these cabinets is going to have a bunch of Danfoss boards in it, and that's like where all your relays are, where everything communicates right there. So like, these are super efficient ways of doing things. It's really easy to work on these things. And now if we come over there, you can see that one. It's hard to get because all this stuff here. I'll go to this rack. You can see right here, now you have a remote header, right? And so that remote header is now going to go off, and we'll probably take a look at that remote header in a little bit. But the remote header offers all the advantages of this kind of system, where it's all really close to one another. It's connected really good. The electrical is right over there. It offers all of those advantages. It's easy for the technicians. All those advantages without any of the with less expense, because it's very expensive to run every single one of those pipes out to your cases, plus armor flexing is very, very, very expensive. So it's a little bit cheaper, a little bit more affordable, and it works out a little bit easier to work on, a little bit more centralized, right, to take these giant pipes right here and run the headers. So I'm gonna go find that header. I gotta leak check it anyway, and we'll, you know, take a look at it. All right, so now you see this is a remote header right there, okay? Now you can see that this goes all the way back to the rack over there, and you can almost think of this as an extension of your liquid header, right? And now these liquid lines will go out to the cases, okay? So you have, you know, this one right here, it's case 25, goes out to the case, right? Hits the TXV and everything, goes out to the case, hits the TXV, goes to evap coil, then it comes back into this suction header right here, right? This suction header will now come over here, you see, goes under there, comes up here, and that goes back to the rack, you see? So rather than having, so I've literally seen loop systems that will put valves on top of coolers, valves on underneath cases, on top of cases. Your valves are just all accessible in the same exact spot. Okay, if you put a, you can even put one of these Parker evaporator pressure regulators, you could put it on this one, a very large one, and you can even have this be its own suction group over here, you know, if you want, you know, specific temperatures on certain cases. And so what this does is, so now we're only running one line over here, right? So we have the advantage of a loop system, which is less cost, and now we actually have the advantage of our other type of system, which is to, you know, have all of these access right here. Now these things will actually become pre-manufactured, so you can just get like this whole frame, and you see how they're rounded off like this. There'll just be a bunch of rounded off pipes just like that, rounded off everywhere. No insulation, no nothing. You just drop it in, bolt it in, and then you can cut them and run your pipes to where you need to go. So if you needed to expand your store, add a department or something, or some type of case thing, you can literally just, you know, run one heavy duty line over here, right? And this will work the same way. Remember, it works off of pressures. Low pressure goes to high pressure. High pressure goes to low pressure. Got that backwards. Sorry. High to low, high to low, high to low. I'm just out of it today. So high to low. Okay, so you have this, 180 psi here, and then you have, 50 psi or whatever this is. Let's see. This is lobster tank. So this is like 55 psi right here. So 150 will go to this 55, and this 55 will go back to the rack because the compressors have are creating a lower pressure at the rack than there is here. Because when that piston goes up, it pushes all of the molecules of refrigerant out of the compressor. Then when it comes back down, the check valve stops any refrigerant from going in. So now it's completely empty of any type of material, and that emptiness is called a vacuum. When there's no material, you're in vacuum. So when that piston comes down, that little orifice inside the compressor is a vacuum. So these molecules of refrigerant are attracted to that vacuum, so this will eventually make its way back to the rack. Not only that, but refrigerant is feeding into here, so there's pressure being pushed in from the evaporators, and that pressure will cause this to feed all the way back to the rack. Now another advantage is communications. So you see this front right here? So now you can just run, you see, coming in through here, a couple power wires and like one communication wire, you see? And then you can have your Danfoss board right there. You can have it all set up. It's all centralized in this area. Rather than a loop system, you might have to have case controllers, a different controller on top of every single case. Type of thing, or controllers underneath the case, or you're gonna have to have, I've seen it, solenoids inside the cases. So now you're gonna have to run lines out to every single case to control these solenoids on these EPR valves, right? It saves on the cost of the electrical. It saves on, the cost on the communication. It saves on the cost of the copper piping, armor flexing, and labor. So these things, and it also is easier for the technician. So that's kind of why they implement these remote headers. So the remote headers work, very similar to a rack, as I mentioned earlier in the video. So that's a real life remote header. And again, so you see one header's over there, and now here's another one right over here. So again, this could be a different suction group. I'm not entirely sure. This is on a different rack. This is rather B3. That header over there was, I think, A something, A2 maybe. Now, this is on a different rack. This is, a different setup. So, it's, let's see. It's a produce one, so this is on a whole different rack, so it gives you more accessibility. You can have different suction groups. You can take advantages of the suction groups over at the rack, and again, it saves on cost, money, and it's a centralized location. And you can even add things like, for instance, you can turn off the circuits from here. For like a loop system, you could kind of do that, but then again, you have to run all the wiring all the way down. This is so much closer. As you can see, you can kind of look at those lines, see where they go, and you can kind of see that, oh, okay, they're literally going right over there. It's a short run, not very difficult. So, yeah. So for a loop system, this is just an example because I don't have a loop system to give you an example on. I work on them not very often. They're more towards the city where I don't necessarily live. So the next time I see one, I'll post an example of it, but this is what we're working with today. So a loop system will be something like this. So you're gonna see, this is for a header though, but you're gonna see a thick pipe like this and like this. They're gonna go out together as a pair, okay? And they're gonna go out to the floor. And you'll see it from the ceiling. You'll actually see, all they do is they'll drill holes in the side or on the bottom or wherever. They'll drill a hole, or they'll put a T in, they'll braze a T in, and then they'll just braze a line out like a tree trunk. And you've got to think of these tree trunks going down, and then it has branches branching off out of it. And sometimes they'll even put ball valves on the branches, or they'll put ball valves at the cases, and those branches will go off to the cases, and then they go, they go into the cases, and then they feed the refrigerant. So this would be, the liquid side, and then it goes back and it branches out, and it comes over here, and they'll drill a hole, graft in another branch, and then that'll feed back the suction side to the rack. So on the loop system, it's going to look similar to the headers, except rather than ending up in a header, it's going to end up in you're going to see it branch off from the ceiling. So in loop system stores, and I'll show an example when I get to one, maybe like loop system pipe tracing. What you would do is you would say, all right, this is my low temp loop or my medium temp loop, and you would just follow it, and you would look for the branches as you needed to. And so sometimes you would actually have to go up to the branches to see what circuit it is, depending on the store, right? So you can see that's the header right there. So it would say like loop 1 or whatever, and you would follow it, and you would look for your branches that lead to your case. So yeah, that's some piping techniques, why you would use a remote header, what is a remote header, what does it do, what is a loop system versus, a traditional system and whatever. So yeah, that's how you do it. Yeah, please like and subscribe. Super helps me out. And yeah, you have a good one. That's how you do it.